Alright guys, day 2 of domain and range. We're talking about discrete functions to start with. Again, domain is the set of all the x values in a relation. We call that the independent variable, okay, or the input. The range is the set of all the y values. We call that the dependent variable, or the output. Those all mean the same thing. Alright, so domain and range for a discrete function. Again, a discrete function is a set of points, right? A set of points. A continuous function is one that obviously continues. Okay, so discrete function, we're going to take our brackets and we're going to list out our x values, -1, -2, 4, and 7. Sorry, let's put the -2 first because we're going to write them from least to greatest. Same thing for the y's. For the range, we're going to look at 1, 2, -4, and -7. So put your bracket, -7, -4, 2, and 1. Mapping is the same thing, right? Only difference is I take all my x's, put them in a circle. I take all my y's, put them in a circle. Draw your arrows to show me what point maps to what y value. So the x's, we're looking at the domain. The x's, this is the lowest, -6, and then 4, and then 8, and then 9. The range, y's, -5, 3, 5, and 7. Now we're looking at a table format, right? The table format, again, same thing as a mapping, same thing as an ordered pair, right? It's just listed differently. Domain is all your x values, so -8, 0, 1, and 2. Range is all the y values, -6, 3, 4, and 9. Now, we're looking at a graph. If it's me, I'm going to suggest that you take the points on the graph and list them out. Right? So this is, here's your origin. This is the first point, 1, 2, -3, -1. This point is at -2, -2. This point is at -1, -3. Now we're going to the right side of the x-axis, so this is a +1, +1, and this is +2, +1. Now, once we have it like this, it's just like that, right? Let's list out our domain. -3, -2, -1, 1, and 2. Range is all the y values, or the output. So the lowest y value is -3, then -2, then -1, and then 1. We have 2 1s, we don't list them twice, we just list them once. Alright, so now, it says what we've seen so far is discrete domain and range, and it's given to us as a list, right? If a relation is connected, you can see how this is continuous from the starting point to the ending point. We're going to write the domain and range in inequalities. Okay, so it says look at the least and the greatest values of each axis, then write sentences that explain the domain and range of each following. Okay, so my inequality statement, this is my starting point. So we're going to start at 0. Nope, sorry. We're going to start at 0. Okay, now we're talking about the domain, so I need the x variable. And we're ending at +7. Now, once again, we're always going to have less than signs. The way I know if it's less than or equal to is by looking at my circles. It's that shaded in, you draw a line. There we go, easy breezy. Now the range is the y values. So I'm looking at the lowest point on the graph to the highest point on the graph. Once again, this is the y variable. The lowest point on the graph, the lowest the graph gets, is right here, which I go over to the y-axis is at -2. The highest the range gets is right here. Now, again, I don't need an exact point. That's not the highest the function gets. That's the highest the function gets. Even though there's not a circle there, it touches up there. It goes up there. The function is there. I can point to it. So that is the biggest range I have, the biggest value for my range, which is at 4. Bam, there it is. Alright, so we got 4 more. We're looking at continuous domain and range. Now look at the difference in my circles here. Those are open circles, meaning that I will have less than signs. Alright, so let's find the leftmost point on the graph. I'm going to scan. Boom, there it is. What is the x value at that point? -5. Now I keep scanning and find the rightmost point on the graph. Bam, there it is, -2. My goodness, that was not hard. Right, so range goes bottom to top. Range is the y values. Find the lowest point. Bop, there it is, -4. Find the highest point. Bam, there it is, +4. What do the open circles indicate? Does not touch. Right, it's going to get very, very close to that point, but it's actually not going to touch, so it's not included. It's not included. Alright, looking at this next one, domain. Again, we're going to scan left to right, so bam, there's the leftmost point on the graph, which is at -4. The circle there is open, so it is not equal to. Now I have an arrow here. That arrow tells me that it goes to positive infinity and beyond, right? Now again, infinity is not a number, therefore it cannot be equal to. The range, the lowest point on the graph, is also right here. The y value at that point is -1 and also goes to infinity. What would the arrows indicate? Goes to infinity, or keeps going. That's not even close to being spelled right. There we go. Alright, two more. Alright, so the domain. So once again, we have a arrow there, right? So this arrow, this line, keeps going. So if it keeps going on the negative side of the x values, it starts at -infinity. And it keeps going on the positive side also, so it goes to positive infinity. And we can also say this is all real numbers. The range starts way down here, which is at -infinity. And it goes all the way up to that point, does not go any higher than that point. What's the y value at that point? +2. And last one, domain. Here's the leftmost point, here's the rightmost point. Okay, here is your axis or your origin. So we went over 1, 2. Domain starts at -2. It is included. And it ends at +1. The range, what's the y value of that point? Down 1, 2, 3, 4, -4. And the y value at that point, we went up 1, 2, 3, 4, 5. Bam, there it is. Domain and range. Let's go!